what we talked about.
Well, I mean, well, when we drew our chart, it was the heat wasn't really the problem. You can get the heat is fine. It was the pressure that was way too low. You know, it just gave you that very bottom of the liquid phase.
Mm-hmm.
So it's the pressure that, you know, kind of is more important. Obviously, you know, you need the solar heating. You know, you need it, you know, to be summer. You need the slope to be facing the sun, so you can get enough solar heat to warm it to that point. But they're kind of already saying that being subsurface, the liquid is already present, given, you know, the ambient geothermal heat and the lithostatic pressure.
If that was the case, wouldn't you see more similar features on the north and south slope rather than just the north?
I guess that does reflect temperatures influence on the whole thing. That's kind of what I gathered from it, was that the sun was kind of the biggest thing. Because what sort of event would even alter the pressure to allow such a thing to happen? I mean, I can't think of anything that would be specific.
Yeah, that's a good question. I mean,
well, other than the impact itself, I mean, maybe that happens like along with the impact, immediately after.
I mean, it could.
You know, and then that's it. These impacts are within 10 years old.
Well, the other thing is that the
surface
has to like settle.
The two were really separate. Like, they were seen in in a few of the recent impact craters. They kind of held that separately. Like, really where these channels are coming is already these craters that have been there and that they haven't witnessed happen. Impact was kind of like a because the impact, they kind of threw the impact rate and these features in together because basically they just took, you know, two separate sets of images, compared them, and looked for the differences. And the differences were, hey, we found a couple of fresh impact craters, and we found a couple of these new gullies.
But if they're claiming recent water activity, then they're all in recent craters or recent surfaces. And erosion rates are typically low in recent times on Mars, so wouldn't it make sense that they could happen along with the process the wall that it's coming from, whether it's an impact or wherever else they're
I
finding
think
it?
these fractures could definitely form in the impact.
I think the whole thing could have.
Yeah.
I mean, I don't see why not.
Could,
I guess is what I'm saying.
The impact could form and give you enough heat and pressure to get.
Yeah, it alters it.
Liquid.
It alters it at a depth that affects the cryosphere. Temporarily liquefies the water.
But that's not the only reason these are present.
I think in order to view the contrast, just visually, between the light-toned potential fluid water deposits in the crater itself, you have to have some degree of settling before these water deposits come out. I think that alone kind of says that these happen later, not during the impact.
Well, this picture right here shows the same crater wall with and without the evidence too.
Yeah, so they're happening regardless of fresh impacts.
Yes,
they occur in fresh impact craters, but they also they were forming in the
stop saying that. They're recent.
Excuse me. But like they also saw them in some of the valleys in like the Valles Marineris region. You know, those have been there forever and they're still showing, you know, some of these outflow channels.
Are they at consistent depths?
Yeah, that's what I was saying.
Like they're all at like 100 meters, or what is the thing you said?
Like, okay, so like take one impact crater. All of the gullies in that impact crater form around the same depth.
Yeah.
It's not like a uniform. It's not like 200 meters all over the planet.
Right.
Obviously, it's, you know, because the cryosphere changes depths and stuff. But like, yeah, they said they all formed a few hundred meters below your surrounding like base level.
Yeah, I think it's kind of interesting. It obviously shares a little information on how we formed a lot of these channels in the past as well. I mean, I kind of envision the same type of situation for a lot of these things. Involving episodic flow in relation to the position relative to the sun. But we are seeing the role that impacts have had on the production of such landforms. Although it's not necessary, because we see these landforms in other areas that are just sloped and not necessarily impacts. But it was also the impacts that initially brought us to this investigation and made us, discover these things. So I don't know. I don't know if anyone else has anything they want to talk about it. But it is pretty interesting. Any questions?
Fluid flow.
I'm still
Recent. You're still
slightly well, Taylor's gonna start talking.
I am a little too.
I'm still slightly confused on the crater age. I understand the ones that they saw, that showed up after satellite was there. But I don't really get exactly how they got the age of the other ones. How they knew they were fresh. I mean, you kind of explained it, but it didn't
What do you
really.
mean the other ones? What other ones?
Didn't you say there was other craters that they used that they didn't actually see form in the last 10 years that they were using?
These are two. There's two different set. Like they. Alright, there is some confusion, and I've seen. Like I understand where you're confused. Like these were two different studies.
Right.
The recent groundwater seepage, or this one, it's the present day cratering rate and contemporary gully activity. This one was all about just how they saw the difference they took the pictures from '99, took pictures from 2006, and they compared them, and they found recent activity, and the recent activity was craters and gullies. Yeah, that was pretty much as far as this went. The other paper is about what are these gullies, how do they form, and this one was where they surveyed, pretty much, like, they didn't survey the whole planet, but they surveyed, like, 40 to 50% of, all the planet. They found a bunch of these places, they look at how they're similar, they look at their features.
Okay.
So
I'm not confused on that.
Yeah, the cratering rate is, the cratering part is not directly related to the formation of these gullies. They're separate. They could be, slightly related in the fact that, okay, if you impact into, cryosphere, you're going to get a lot of this gully formation, but it's not necessary to form these gullies.
Maybe the gullies are of different ages.
They are. In this one, they had said that they didn't see any fresh ones. They were just taking all of them and finding the similarities between all of these gullies, no matter if they were, because they didn't know how old they were. They have no way of dating them really unless they see them like they did in this one paper. In this one they only saw, I think, they have the pictures of them like 2 or 3 separate occasions where there was the recent activity. This one was just target the gullies and figure out what's going on.
If you want to think about it in terms of how they initiated all this, it was basically just like observing Mars, and you see a dark spot that you've never noticed before. So you're like, well, what's that all about? And they basically use their cameras and whatever they have in orbiters to identify it and start looking at it in more depth. Upon further analysis, they realize that there's more craters coming in and forming on the planet. So they kind of established a wide-scale investigation of 3 specific areas. And they were Tharsis, Arabia, which I'm not quite sure where Arabia Terra is. Oh, over here. And Amazonas, over here. So they're all pretty much above the equator, right around the 30-degree latitude point. Anyway, this investigation created even further discovery on new areas that they had not identified before in terms of new dark spots. And I must mention that the study is predominantly in areas of high albedo, just because that's how you're able to see them.
Like you can see like the one picture of the present day impact crater rate paper, figure 1B, it's kind of lighter terrain, and then you can see the impact crater itself, like dug up a
basically what they did was they established new images in an attempt to map these areas presently, and they compared those to those created back in 1999, and with comparison we're able to identify what surfaces are new, and they actually identified 20 new impact sites, which from 39 original candidates that they were analyzing, they produced 20 that were, fresh impacts since 1999.
Did they try and use this to adjust the crater density?
No, they just correlated with the crater, with like the kind of model that we have for crater density, and that's what they found. They said it was consistent with the crater that we have modeled, the number and size distribution. It's the model that
The way you said that makes a lot more sense than the way you said it before. So
Okay,
I'm
sorry.
happy now.
So it's kind of the investigation of these fresh craters that led to these gullies being interpreted as water deposits.
Right.
Which,
Not necessarily.
well, yeah, because there's other ones too, obviously.
Well, it seems that the part that I'm having a hard time reconciling is that I don't think that there's conclusive evidence that these gullies can adequately be grouped into one population. Because if you're looking at these recent impact craters show gullies, so we know that's recent activity. But then we have gullies elsewhere. You can say that they most likely all formed from water, but it doesn't necessarily mean that they're all the same population. So I don't really
think we ever made them
see.
something that was the same population.
No,
All
we're just
related.
talking about them completely separately.
Yeah.
But then I don't really get how they're claiming then that there is evidence for recent
Because of
water activity. Because those could have been induced from the impacts.
no,
The ones just within the
these
craters could
outflows.
have.
The craters were there in both images. These craters are really ancient. And picture one.
I thought they were fresh and recent.
Those are different. Those are completely different craters. I think Marty might have spoken weirdly, but yeah, like
Sure,
these
Paul.
craters that they found, the craters that they found the outflows in were craters that are already there. They didn't witness the formation. This paper was on recent activity, and what the recent activity that we found was cratering and gully formation were the two recent processes. They're not necessarily related. They can be, obviously, but it's not the assumption that they made.
That's Lee's article. My article, which I abstracted, was present day impact cratering rate and incident zones and zones. So that's where the confusion kind of derives. His is like an overall analysis, and mine was in relation to it.
Yes.
So do you guys think there's sufficient evidence to say that this is in fact liquid water on the surface, or not?
Well, they talked about that, where they compared, like, these gullies that they think, are liquid water, they compared them to other things that are interpreted as, solid mass flow, mass wasting on the surface.
Or maybe evaporates? Did they
Like,
compare it to possibly those are, maybe those were old fractures filled with ice and the sun hits it and
okay.
sublimates
can
and
see where
leaves
you're going.
behind.
No, they didn't go down that road. But like, they said there's really characters.
Yeah.
Why
is that?
I think you're way off. I don't think you're going to have an abundance of evaporites forming along contacts and then depositing material beneath the contact downslope.
They might be associated with fractures, like that might be where the water originates, is along some sort of fracture, but then it still flows downslope. They said there's a lot of clear distinction